If we take a look at number 5 on here, this is on the superhero logic sheet. Number 5 says, villains rob banks. So before I try to evaluate that for true, false, or validity, you're right. I left 4 off. I'm going to leave that for you guys to think about. We take a look at number 5. How do I take villains rob banks and write an if-then statement out of it? What does that become? Okay, so if you're a villain, gentlemen, thanks. You rob banks. Hey, guys, that's twice now in less than a minute. Whatever the conversation is, it can stop. And there you go. Thanks. All right, so that's my if-then. It says here that Medusa is a villain, so we conclude she must rob banks. Does that follow the law of detachment?
No.
If you're not sure, let's make a Venn diagram of it.
It doesn't. No.
Here are my 2 groups. There's group 1 and here's group 2. Which is the inside circle?
Villain.
If villain, then rob banks. So villains is in there. Robbing banks is there. If I tell you somebody is in this group, does it follow that they're in this group? Yes. So, if you're a villain, you rob banks. Medusa is a villain. Therefore, she must rob banks. That's valid. Now, the catch with this, it might not be true. You might say, wait a minute. Villains do lots of other things. And there are some villains who don't rob banks. You know, you might find a counterexample, a villain who doesn't rob a bank. Maybe they just take hostages. Or maybe they just drive really fast. Or perhaps they park in handicapped spots without proper permits.
Oh my God.
I know!
How would I
My dad has that.
Okay. Okay. That may be true. But we're not asking for true, false. We're asking, does it follow the rule of the law of detachment? Which is, if P, then Q. P is true, therefore, Q is true. And this is following that format.
So why do they call it P and Q?
P represents the, well, we just have to use some letters. We use the ones in the middle of the alphabet because they don't get used for a lot of other stuff.
So they're like...
They're there, they're fun, they're good to use. Because X tends to be the default variable for algebra. A tends to be the default algebra for geometry. So for logic, we grabbed P.
I got it.
Okay, now we'd look at number 6. 6 is a little different. It says villains rob banks. That part hasn't changed. Let's put that back up here. Simon robs banks. Does it follow that he's a villain? Going to this Venn diagram, if I put Simon on there somewhere, does he have to be in the villain group?
Yes.
Now he's in the bank group, but is he necessarily in the villain group? What if I put that dot right there? That's Simon. He's not necessarily in that villain group. He might be, but it's not a guarantee. Because what's happening with this argument is we're using if P, then Q. So if you're a villain, then you rob. Excuse me. If you're a villain, then you rob banks. This person robs banks. Does it follow that they're a villain? Is that the law of detachment? No.
But in real life, that's how.
Now again, you're thinking truth. Look at the argument, and we're just following the rules.
This is really confusing.
It can
It
be.
should be called the I and T. Because it and then.
You could think of it that way. Or actually, what I would prefer to call it,
What?
H and C.
Why?
Hypothesis, conclusion.
Got it. See, that's what we should call it.
Yeah, let's do that.
But, we use P and Q because that's what people have been using. When you take your first class in semantics in college, which is usually offered in the philosophy department, a lot of colleges give credit for it. Everybody uses P, Q, R, S, and T. It's just what they do. When you take linear programming or introduction to analysis in the math department, you're going to see the same format of P leads to Q, P is true, therefore Q is true. That is the law of detachment. That's valid. And then a common mistake is if P then Q, Q is true, therefore P is true. And that's just the way it works out.
You said that